All right, hey everyone. I'm Daniel. I'm probably you've all talked to me at Walrus. I'm here to introduce you to Walrus, show you the overview of what Walrus is, explain why you should use it, and show you how to start using it in your hackathon project today. So for this workshop, I'm going to start with a quick overview of what Walrus is, and then I'm going to show you some quick, easy ways to interact with Walrus. Walrus is pretty simple. We're reading and writing data, so there's not much to it to get started. And then I'm going to go over some products that we have built on top of Walrus already. For example, Walrus Sites, which I'll get into later, and then I'll leave the workshop with some more resources for you guys to use. Okay, so for those of you who don't know, Walrus is a decentralized storage platform. So you can read data, you can write data, you can delete it. And you guys might have been familiar with existing decentralized storage networks, but the way Walrus is built with a lot of lessons. No, they have headphones on. So Walrus is built with a lot of lessons learned from previous decentralized storage networks, and I'm going to show you some of the benefits that Walrus has that's unique to it, Walrus. So replication, when users have to store data on Walrus, the data is replicated 4 to 5 times. So for example, if you want to store 1 gigabyte, the network itself uses 4 to 5 gigabytes worth of storage. And this may seem like a lot, but most prior decentralized stores require full replication. So this means that every node typically has to store a copy of everything that's stored on the network. And we are able to accomplish this because the team at Walrus created a novel 2D encoding algorithm that allows us to shard the data, but still shard it in a way that only needs to be replicated 4 to 5 times. And because we have a constant replication, Walrus is very scalable at the same time. So because adding networks or adding nodes to the network will actually improve the performance of the network. The more nodes there are, the more throughput for reading and writing. So you may think that with 4 to 5x replication, the fact that not every node has a full copy of the data, that there may be resiliency issues, but this isn't the case. Walrus is very resilient. People can still write to the network even if a third of the nodes are down, and you can read the data that you've written to the network even if up to 2/3 of the nodes are down. So you can see that with our new novel encoding algorithm, we are much more cost effective as far as storage goes than other decentralized networks that have to do full replication, but we're also a lot more resilient than the networks that do other methods of sharding the data. In addition to this, Walrus is also very programmable. Walrus uses the SWI blockchain as the coordination layer for Walrus, and I'll go into detail about this later. But what this means is that storage capacity is now tokenized as an asset and is on chain to be used in smart contracts. So this opens up a whole bunch of opportunities there. And in addition to the typical delegated proof of stake mechanisms, we also have novel algorithms that use to attest the nodes. The nodes can constantly challenge each other to make sure the data that is stored on Walrus is secure and accurate. Okay, so what does it mean when I say that SWI, the blockchain, is the coordination layer for Walrus? Typically, other decentralized storage networks, they have to use some sort of custom blockchain or VM to coordinate all of the metadata and global states for the network. But this isn't the case for Walrus. Walrus uses SWI to do all that management for it. And because we use SWI, this allows us to build Walrus with the complete focus on reliably storing and writing the data. And in addition to this, because SWI is very fast and reliable, this also makes Walrus very fast and performant. So in addition to being able to design Walrus with a specific focus and being high performant, using SWI also allows us to program this proof of storage and availability, which means that storage capacity becomes tokenized and is an asset that can be used on chain. So this really opens up a lot of opportunities. Now you can use storage, you can have storage in marketplaces on chain and other aspects. And this also can be used to manage the data ownership as well. And because we use SWI, there is a native utility token on SWI for Walrus, and this Walrus token is used to steer the network economics, incentives, as well as payment for the storage capacity. Okay, and I just wanted to make note that even though Walrus uses SWI as a coordination layer, Walrus is completely chain agnostic. You don't need to be building on SWI. You could build on Ethereum, Solana. You could build on no chain. You could build a completely Web 2 app and still use Walrus to utilize the decentralization and reliability of the data storage. Okay, so that's a little bit of an overview of what Walrus is and why it's different and newer and fresher and better than the other existing data stores. So this is the environment that you'll be looking at with Walrus, and the first way that you can start building with Walrus is through the publishers and aggregators. A publisher allows you to write data to the network, while an aggregator allows you to read that data. And you can integrate into these publishers and use them with either an HTTP API or with a web browser interface. So let's try this out. I encourage you guys to take out your phones and scan this QR code. It will take you to a demo app that we have that allows you to start uploading stuff to Walrus. No CLI or any installment, no installing required. So I'll give you all a moment, and then I'll navigate there myself. Okay, so what we have here is a demo app that we have that allows you to upload blobs. Blobs are the data that is uploaded to Walrus, and this uses a publisher and an aggregator and it integrates this with an HTTP request. So I'm gonna choose a file to upload here. I can do this little avatar. So upload that. And Walrus uses renewable leases, meaning you only pay for the amount of time you want to store your data for. You don't have to pay for 200 years up front, and there's no minimum size or anything like that. So an epoch in Walrus is a day. So let's say I want to make this available for 10 days. So I can hit upload. And we'll see how fast this is. The Wi-Fi isn't the best, but we'll see. Okay, cool. So we can see the image so the image has loaded here, and we can see that this was newly created, and we get two things back. We get the blob ID. This blob ID is what is used to identify this specific content on Walrus, and I'll show you later that this is the blob ID that you'll use to read this data at any other future time. And then we also have the associated SWI object. This is the address of the object that represents ownership of this picture. So whoever owns this object on the SWI blockchain is the owner of this data and can choose to delete it at any time or also renew its lease and extend it further. And we can see here that this is the epoch that this picture will no longer be guaranteed to be saved on Walrus. Okay, cool. And for those of you who want to go further, let me refresh this. If you go to the docs page, under usage, we'll have the docs for the HTTP API, and you can see how to do all the things that this demo app is doing. So here's a list of all of the public aggregators that we allow and all of the public publishers. And then it's as easy as just writing a command like this. You can use curl even, and then just v1 store, and you can specify the number of epochs and then the file you want to upload, or a string in this case, and you get a similar output to what was shown on the demo app. And then it's a similar thing for reading, but it's even easier. You just type in the blob ID here, and then you'll get that file back. And I'll show you this using the CLI in a moment. Okay. So that is one way to interact and start building with Walrus. And the second way to do it is through the client directly. And we have a Walrus CLI that allows you to do this. So I'm going to show you a demo video of this. So these are all the commands that you're able to run on the CLI. You can read, store, get some information, as well as some other things. So this command will tell us the current information for the network at the time. We can see like the current epoch as well as the cost to upload certain sizes of data. And now we can go ahead and store something. So we'll use the Walrus store command. We'll specify the number of epochs, and then we'll input a test file, which is, in this case, it's a text file. So right now the data is being split up and distributed to all of the different nodes in the network. Okay, cool. So after a successful store, you'll get the blob ID as well as the suite object ID that we saw in the demo app. So I just copied this blob ID so that way I can go ahead and read this data. At this point, anyone on the network can read this data. So Walrus, read, and then the blob ID. And then at this point, the data will be retrieved and displayed on the terminal here. So we can see that this was the contents in this text file. Okay. Okay, and like I said earlier, Walrus uses SWE as a coordination layer, which means you are able to build on Walrus using SWE smart contracts. So this is a third way. It's out of scope for this hackathon, so I'm not going to be showing you exactly how to do that, but if you're interested, you can always come by and ask us and we can show you later. Okay, so that's the basics on how to use Walrus like in a hackathon project. There's not much to it. It is just reading and writing, and we wanted to make it as simple as possible, so there's not much instruction for it either. But I wanted to go over this product that we have on Walrus called Walrus Sites. Walrus Sites allows users to deploy decentralized websites onto Walrus. So you can go ahead and deploy and upload the static image files to Walrus, and then we're hosting web portals that allow you to display these sites. And just note that the web portal aspect is decentralized, and anyone else can host their own portal. So you're not relying on the Walrus protocol to display the sites. And we've actually seen that in previous hackathons. We've seen other people host their own portals. So at this point, I want to show you an example of Walrus sites. So we have this NFT minting site called Flatland. You can find it at flatland.walrus.site. I can provide the link for this later as well. But so what this is, it allows you to mint a new NFT, and this NFT has a specific shape and color to it. But the cool thing is that each NFT has its own Walrus site associated with it. So this really you can kind of read it down here, but so every NFT has a unique site, and I can show you this here. So I'll mint a new one. Okay, so it just loaded. It just replaced the old one I had here. So we can view the site. So this website is completely specific and unique to the NFT itself. If you go to the NFT on the Explorer, you'll see that it has this purple color and this amount of sides on the shape here. So this is an example of how you can use Walrus sites in a decentralized manner. Every NFT can be viewed by its own website, and also to note that the owner of this NFT is the owner of this website. So at any point, if the owner of the NFT wanted to update the site, they could do this because they own the actual NFT. Okay. Yeah, so if you guys wanted, I didn't go over the details of how Walrus was built or the algorithm that we used to split up the data, But if you're interested in learning more, you can scan the QR code on the left, and this will take you to the Walrus white paper. And then if you want to look at all the links all the websites I showed right now and access to the docs and everything, we have the starter pack on the right that you can scan. Okay. Thank you. I want to thank you all for listening and being interested in Walrus and potentially building on Walrus. And I'd love to take any questions you have now. And if you have any other questions that you'd want to take personally, I will be at the Walrus booth in the other room. So yeah, thank you.